Everyone, here's someone from the studio. Welcome to this new video. This time we will work with pop and gel cell copy pop. As you can see here, I am rendering an amplified version of the Flex. Okay, so the particle simulation is the Flex solver. And as you can see, we are having multiple objects going around, making stuff. And by the usage of the Flex solver, you can have collision forces wherever you want. So it can be calculated. So it's very, very nice. The whole project will be shared on my Patreon, so you can have a look. Now I will describe something, but the lesson of today will be this, basically. A shape pool, which you can then read in the GLSL copy pop and put a randomized selection of those shapes into the point we will pass inside the GLSL copy. So the GLSL copy has two inputs. One is the source and the other is the template. Okay? Source, template. As the copy, or pardon, copy soft. So same things, but way more complex. Since here we're dealing with the subclass, which is in the CPU. Numbers are dealt in that way, and they are calculated that way. Here, we are running a compute shader, which is freaking fast. Okay. And there you have with the Zomatica API. Okay, so this is why we want to use the GLSL copy. It's fast and nice. Okay. Let's start analyzing the patch that we will not build, but at least when you open it, you know. You can have a look with me. Okay, nice. Let's initialize everything. So no simulation. Let's start simulation. I did not find a way to get rid of this disaster in the middle, but yeah, whatever. So this is the Flex solver. Okay, Flex solvers require actors and forces. Actors to make stuff appear, and forces if you want, moving forces. We inside or back inside. Yeah, inside we have the actual actors. So we have the collider, and one emitter. I took this and analyzed it, modified a bit from the snippet. Oh, snippet, yeah, I pronounced it correct. You go to solver, emission. I guess this one. Yeah, I took it from here. Easy. Okay. There is a problem on the beginning of everything, which is this one. Those are non-pixel, and this is actually fucking destroying everything later on. So we have to solve this problem. None means not a number, or not. This kind of things. Not a number means not a number, so it can be represented. There's a way. We can, but not now. Okay, yeah, this one. So it's this kind of. I didn't know it, so I asked to Germany, actually. So, but I know what it's doing, so let me describe it. We are creating a Boolean value. Boolean value is true or false inside of the other side. Okay, basically a 0 or 1. It's a byte, byte, whatever. Okay, any means since we are checking something that return a value, this value has not a type. You have to say just go any. Okay, then this is to say inside we have something. Okay, Then there is a function to check if you have problem, which is none. It's inside of the GL cell. OpenGL will give everything here. 4.3, but I guess 4.6 will be okay. Doesn't really matter. So I don't know. Keep it big. So inside here, we are checking something. It's supposed to be a vector, and in this case, a vector we take it from a texture, which is this. Okay. And the texture, you can read it via a function, which is returning, it need a sampler and a sampling point to give back you the data. The sampler is predefined by that design, this input here. And then since we are working with the texture, we can rely to UV as a sampling point. These are the UV. This is a predefined vector. Inside of that design. Okay. So then we have something. Okay. Inside here, we are doing an if statement, very smart. Okay, so we are you can do it very fast also because it's a Boolean variable, so to check it is easy. So if this means if none is actually none, then please return a back for 0, means all black. So we are cutting out the none. And here we are saying this is the, if you do like this, so you're checking a Boolean, it's true or false. Then after the space, you need to define what is yes and what is not. This is the short. If not, you need to write an if statement with it here. Oh yeah, well, something. No, it's like this. So that was last you make a comment. You can say if the condition, and then action, which is the long way of doing this. Action. So the condition is this one, in this case, and then the action, you don't even need to write it because you're using the short version of this. Here, okay, yes and no. True or false. Okay. Very long for a very short line of code, but hopefully you learn something. Very good. Go. Again, thank you, Gemini. I didn't know it, so but good. Okay, let's go forward. So we have points here. We can see those beautiful points here. Go. Oh. Okay. Oh, yeah, a lot. Very good. With those points here, we're doing some stuff. First of all, we're going in pop. And so to set shape probability. Because we need to actually start to think about the flow of data we need to put here. Okay, so first thing first, here we go, shape probability. Okay, then here is also a trick, very important trick. Okay, so we have we need to sample a texture, and this texture needs a sampling point, which we do not have here. Okay, because from here, from top, we just have points. Okay, but those points are in a texture. Okay, which then we will pass to pop, and the texture will be organized as they want. So I'm taking here the number of points, which means how big will be this in pop. I'm not doing it from the resolution here because sometimes change. So that's at least when you are in pop. So you take the number of points from this info. Why? Okay, this is a thing I already explained in my tutorial, very old, the one of the unwrapper. So I was trying to make something to work with on the GPU. Now we have the pop for it, so we can use something, learn a lot of tutorial ago, which is making a linear index in a two-dimensional index, meaning we take the point index on the incoming pop, which you can arrive from here, back normal attribute you should not change. The underscore mean for a variable that is internal. You should have an underscore and a name. His name is a variable. Programming wise, it's internal, can't be changed. Okay, you can use it, but you have to return something else. Basically making a copy. Okay, underscore means this. And we're doing some math. Okay, I don't want to go again and explain. So the first part is actually repeating. So because if you imagine you have a line, okay, let's do it again. This draw. Okay, we have a line. This is our linear index from 0 to 100. Okay. How many steps we have here from 0 to 100? 100. Okay. So we take the square root of this, which is 10. Okay. And then if you make something 10 by 10, you are folding this. Okay. You're folding this. And you have it's always 100, let's say, pixel in one line. You put here. It's what Paqueta do all the time with their debug stuff. So this is the concept. But now we have to do the math our own, which is this. Okay. So we have now for the first part, you need to do a modulo, because the modulo return the is actually when you go, how to describe it, when you return from a sentence. Okay, you take a text, you write something, say hello, let's keep 4 letters. Okay, hello, and then when you press enter, the second time you do a modulo, you can type another 4 word letter, word or letter, word, yeah. Okay, so basically here we're doing a modulo. Okay, nice. Is what is doing the module. Then the second one, you need to divide. And if you divide, basically you get how many row you have. And with the module, you get the columns. Okay. This also kind of intricate explanation, which is really used, one-dimensional, two-dimensional array, is used to sample these things here, which I can change. And as you can see, we are actually breaking everything, because we need to rewrite the point where if I change this, something froze because we are we should like pop stuff. Yeah. Okay, so basically we're changing which one is which one. The frozen part is because you are writing another value in another frame, and then they need to update because it's updating every point, these things to be faster. Anyway, so this is for the probability. As you can see, I can change this, and then I free the memory. You have the new version. You can't do it real time. Then the shape probability, my code want to be used as an integer. And nice, now we have here we're doing the UV to read the texture, so that we can read as many textures as we want. So we can even create the shape probability, but also set to this point other attribute, which is the rotation, which is a very cool thing. I don't know how I got it, I don't know if it's correct, but visually it's nice. So you see those stuff are also like rotating from based on how they are going and how much they're moving. She's not maybe physically correct, but it's a behavior I like graphically. So yeah. Here, angular momentum, how to calculate a directional vector. You remember where you was, and you subtract it from where you are. easy. Okay, but then we need representation of how much we are moving, and basically the difference of this will be bigger if you move a lot from a frame to another. Okay, so I cut the 3 axes and get a mono version, okay, of all the axes. So this is a black and white representation of how fast I'm moving. Okay, so if you see this line is where we are emitting, which is this, which, as you can see, they are a bit faster when they burn the particles. This is why we have this very white. In the X, same stuff here, and same stuff here, which makes sense because they go like this. Okay, then we, with these 3 calculations, make another texture, which is not equal to this one, even if it's very similar, it's not. To this, we want to add a start rotation, which is a very, very small value. And this is actually a mark to say move and a half of what you're supposed to move, because we are engaging a feedback here. Okay, so this is every frame. We're keeping track of how much we should rotate based on our movement. Whoa. And yeah, here I'm cleaning a bit texture, but it's not working as I want, so whatever. Yeah, this is what is it? This is the scale. So again, here from this I take a mono, which is actually calculating how much is my rolling friction, incoming rolling friction, and I'm using this for the scale. I don't know why it looks good to me. And yeah, so if I arrive with this thing which is full of stuff, very much full of stuff. Yeah, I am also creating. I'm painting in here. Let's see. Okay, so we have position, the probability of where which shape should I be, the rotation, which is the rolling friction thingy, the size based on the rolling friction thingy, and the 2 attributes which I'm using to read the texture unit. This is the end of our template points. Hey, nice, bravo, bravissimo. Okay, we got until here, so this part is complete. This part now we build, and then we write a very, very, very simple line of code, which is we won't even use this one. Maybe yes, let's see. The trick is here. Okay, make it big. Big kids here, big, very big. Okay. So as I showed you before, how to write an if statement in JSL, there is always the same language, but we are dealing with other topic. With POP, you have a naming convention to call function. Okay. Those functions are automatically created from the compiler of data design, so to match the attribute name you give in POP, you can read it in the GLSL, so naming convention. Okay. In the GLSL POP, copy POP, we have a template and an input. Okay. TD in refer to the input. TD template refer to the second input of the GLSL POP. Prob stay for probability, which is the name I gave to the attribute. So you refer to an input, you then type the name of the attribute, and you call the function so to have the stuff you need so to have the data. Okay. This is inside parentheses, normal parentheses, because if a condition of an if statement. Okay. The double sign means you should be equal to what? Because we're using it as a condition. Okay, equal to what? Okay, TD in the first input of the JSL copy POP, we want to check the ID. Okay, so if the probability, which is an integer, is equal to the ID, then you copy something. Okay, so to address an output attribute, you need to use this syntax here and allow the JSL copy to write in there. There's also read and write, only write, but too much for now, so you have to define it here. You will do it together later, but very long tutorial, at least you have an explanation. So to refer to an attribute P, which I define the operator there, you have to do this P, and then being an array, you have to give us something to process this array, which is an ID. The ID is created here. This TD index is the same we used here. It's the same things we are using here. Underscore point E inside here become TD index. You can call it range. Then you create an ID, which is a very special type of integer. All right. So you can then write to each allocation of the array, which is a vector inside here. To P is the point position, then the normals. Okay. Here I'm doing the rotation thing, so to apply the momentum, the rotation, the angular velocity thingy, and I then multiply the point for the template size, where we have the attribute, and this. Okay, then I am offsetting everything from the template position. Okay, so this one is referring to this geometry, so this geometry string. And the template is referring to the flex. All right. Yeah, for colors, I'm just using some colors, which I am defining here as an attribute. No color. Nice. Okay, this is how we're using flex with pop, JSL copy pop, and augmenting the capability of the flex by the usage of some math and top. Thank you very much for your time. Some maths, pardon. Thank you for your time, and see you in the next one. Ta-ta-ta.